Hello everyone, welcome to MES's e-learning channel. So today we are going to learn something about nanoscience and nanotechnology. So these are the different particular subtopics that we are going to cover in this chapter of nanoscience and nanotechnology. To start with, we are going to give a small introduction to nanoscience and nanotechnology. This will be followed by a brief discussion on surface to volume ratio. Next will be the two main approaches that we use in nanotechnology. This will be followed by important tools in nanotechnology. To start with, scanning electron microscope. This will be followed by transmission electron microscope. Next will be atomic force microscope. In the synthesis part, there is a synthesis method of nanomaterials. We will be having ball milling and salt gel to start with. This will be followed by sputtering, vapor deposition, thermolysis, and later by laser ablation, RF plasma and RF plasma technique. Now, in the end, we will actually be studying the applications of nanomaterials, rather two main applications of nanomaterials. So to start with, whenever we are saying nanomaterials, the word nano is very important. And as you know that the word nano is nothing but 1/1,000,000th of a unit. So when a unit is 1 meter, then what you are speaking of is nothing but of the order of 10 raised to minus 9 meters. So any material that are actually from, let us say, 1 nanometer to around 100 nanometer, these materials are actually classified as nanomaterials. In order to give you some kind of idea regarding the nanoscale, let us compare it with certain objects which we have seen or which we normally see in our daily life or which we come across them in our daily life. So for example, the atom, which of course you cannot see it, but rather you have known of it the minute you have been introduced to the atoms. So this is of the order of 10 nanometers. This is followed by a biological species which is amoeba, which is of the order of 10 raised to 4 nanometers. And lastly, you have this myself, which is of the order of, or rather my length can be taken in the order of 10 raised to 9 nanometers. So in the next slide, what we are going to study is nothing but the classification of nanomaterials. So what are the different types of nanomaterials? A nanomaterial in which the nanoscale is extended only in one dimension, then such a kind of nanomaterial we called it as nanofilm or a nanocoating. Next, if the nanoscale is extended in 2 dimensions, something like this, the nanoscale is extended actually in 2 dimensions, then what we have is nothing but, as you can see, what we have is nothing but either a nanofiber or a nanotube, so as to say. So we have examples of this are nothing but the carbon nanofibers or the carbon nanotubes. You can see the same images of these carbon nanotubes and nanofibers. And of course, as the third case will follow very naturally, that suppose your nanoscale is extended. So these are the 2 dimensions which are there, and suppose if the nanoscale is actually extending even for the 3rd dimension also. So what we have is nothing but a nanosphere or a nanoparticle, so as to say. A very important example in this particular category are the gold or the silver nanoparticles, so as to say. So what happens in a gold or silver nanoparticles? You can see that what you have is, these are gold nanoparticles. Mind you, they are not yellow in color. And once again, there is a range of nanoparticles of gold, and we have this at one end. The difference between this sample and this sample is not only the color, but rather the size. So this is around 30 nanometer. So the dimensions of this or the diameter of these nanoparticles of gold is 30 nanometers, and this increasing in size, this is right up till 90 nanometer. So correspondingly you will see that there is a change, there is a variation in the color, and this is maybe this is more towards the reddish side, and out over here this is more towards the violet, or you can say even the purple side. The reason for this is the minute you are synthesizing a particular material in the nanoscale, the electrons are confined, and due to this confinement their energy level changes. And since the energy level changes, as you know, that color is nothing but what? It is nothing but when an electron drops from a higher orbit to a lower orbit. So this orbital distance changes, or the difference in the energy changes, and that's the reason why the outcoming radiation which is there, that is actually going to change, and hence you can observe a variation in the color. So now we tend to define what do you mean by nanoscience and nanotechnology. So nanoscience is nothing but the study of nanomaterials. This means nanomaterials, as you know, are those materials whose dimensions are of the order of 1 nanometer to around 100 nanometer. And then what is nanotechnology? Nanotechnology is nothing but the engineering of functional systems at the molecular level. So with this, the next thing which you are going to study is what will be the preferred size, or what will be the preferred dimensions for making nanomaterials. The preferred object is nothing but a sphere or a cube. I will say the very simplest one is nothing but a cube or a sphere. So let us see which one will be more preferable as the basic unit in nanomaterials, or rather in the fabrication of nanomaterials. Let us start with sphere. So to start with, let us start with a cube. Consider a cube. So we know that the surface area of a particular cube is nothing but 6a square, wherein a is nothing but the dimensions of the sides, the cube, the length of the cube. At the other end, suppose you are saying the volume of the cube. The volume of the cube is nothing but we say it is a cube, and let us assume a cube of unit dimensions. So in this case, the ratio of the surface area, which is 6a square, to that of the complete volume, which is a cube, this particular ratio will turn out to be 6. So I can say that the S upon V ratio for a cube turns out to be 6. Now let us compare this with the case of a sphere. So we know that the surface area of a sphere is of the order of 4 pi a square, and the volume of a sphere is of the order of 4 by 3 pi a cube. So now let us consider a sphere of unit dimensions, and let us consider this ratio of the surface area to the volume, and it will turn out that it is turning out to be 3. So when you compare this with that of the S upon V ratio for a cube, which is 6, immediately you come to know that the S upon V ratio for the cube is more, rather twice, that of the S upon V ratio for a sphere. Hence, while using any technique to prepare a nanomaterial, it is always preferable to use a cube as the building block. We once again delve a little bit more deeper into this particular concept. So this is our main conclusion, and this is what we delve a little bit more into this concept of how a cube actually dominates over a sphere. So in this case, what we have is nothing but the building block of a cube is nothing but we have a cube of dimensions 1 centimeter by 1 centimeter, right? and there will be 6 such faces, and therefore the area is, let us say, it will be 6 centimeter square. Compare this with this this cube. So what in this case what we do is we actually reduce the dimension of each building block, and we see to it that each building block is of the size of 1 millimeter. The surface area now increases to 60 centimeter square. And in the third case, the size, the length of the cube remains the same, but the size of the building blocks, I am reducing it to 1 nanometer. And you will be surprised to know, you can make a calculation for this, that the total surface area has now increased to 6 into 10 raised to 7 centimeter square. So as you can see that as you decrease the size of the building block, this leads to an increase in the total surface area. This is one of the tricks that is being utilized in making nanomaterials. So next, we are going to study the 2 main approaches in making of nanomaterials. So what are they? Let us have a look at them. The first approach is nothing but the top-down approach. So what happens in this top-down approach? Let us say you have a chip, or you have, let us say, a rock, and then you carve out a statue out of that. So this is something which is called as a top-down approach. Only thing is, this approach we are using it at the nanoscale. This means you have a bulk material and you either cut it or you either grind it, right? And you use it to make a nanoscale frame in that particular material. So this is called as the top-down approach. Here is an example of a top-down approach wherein E-beam lithography is being utilized. Over here, what you have is nothing but an E-beam, or a E-beam means an electron beam. And this actually falls on the material over here, and you etch out a part of the material, the desired part of the material, and this particular part is on the nanoscale. So this is how actually you used the top-down approach for making of nanomaterials. So next we study just a tree or the classification of the top-down approach. So as you can see over here, this is our top-down approach. The different techniques which are being used in getting the nanomaterials using the top-down approach are lithography, an example which you have seen in the previous slide. You can also use cutting, etching and grinding. So lithography and cutting, etching and grinding. And examples of this are for the manufacture of electronic devices and for the formation of chip masks. So remember, any electronic chip has a particular mask for making it, and this chip mask can be used by such a kind of approach of lithography. Under cutting, etching and grinding, the examples of this are precision engineered surface. So for example, highly polished glass surfaces, the one which was, let us say, used in the Hubble Space Telescope. Over there, you are using either cutting, etching or grinding. So we have seen the top-down approach for synthesis of nanomaterials. Next, we are going to study the bottom-up approach for synthesis of nanomaterials. As the name itself indicates, the bottom-up approach actually indicates that we are actually going layer by layer. So we are actually making atom by atom layer generation, and that's how actually we make up the nanomaterial. The devices that are actually formed by using such a kind of approaches are very compact. But at the same time, the bottom-up approach is not as simple as the top-down approach. Here is an example of the bottom-up approach wherein you have synthesis of the central zinc oxide, the central zinc oxide rod, right, by layer arrangement of atoms. So this is nothing but usage of the bottom up approach. Next, we are actually going to study that how is it that we are going to classify, or what are the different kind of techniques that are going to fall in this bottom up approach. So these are the just a classification of the different kind of techniques which we are using for the bottom up approach. And what are those? So this is your bottom up approach over here. What we have is nothing but the chemical synthesis over here. Then we have the self assembly, right? And we have the positional assembly. Under the chemical synthesis, what we have is either the particles or the molecules, synthesis of the particles or the molecules. And under the self assembly, we also have the example of crystals and films. So the example which we had given in the previous slide was actually belonging to this particular category of self assembly. So students, this brings us to the end of this particular video lecture. Here is a quick recap of what we have learned in this video lecture. So first, we gave a brief introduction to nanoscience and nanotechnology, understanding what do you mean by the nanoscale and what do you mean by nanomaterials. Next, we studied the very important parameter of surface to volume ratio of two figures, and these are spheres and the cube. And we came to the conclusion that the S upon V ratio of a cube is 6 as compared to the S upon V ratio for a sphere, making it, that means the cube, a very likely candidate for being the basic unit in the manufacture of nanomaterials. And lastly, we studied with examples the two main approaches for making of nanomaterials in nanotechnology, and these are nothing but the bottom up approach and the top down approach, and we also studied the examples in each one of these approaches. Thanks students for your kind attention, and I hope you have understood the details of today's lecture.